Okay, I hope I'm audible to all my students who are attending this particular lecture for the introductory econometrics course. In this particular lecture, I'm going to continue with the discussion of the 2024 question paper, which has come up at Delhi University for the introductory econometrics course. And this lecture is recommended for all those students who are in their semester 4 pursuing BA Honors Economics from University of Delhi. Now, all my students can recall that in the previous lecture, I had just solved a few parts of question number 1, which all students can currently see on your screens. This is question number 1, and it's a true and false based problem. We had solved parts A, B, and C in the previous lecture. Now, in this particular lecture, I'm going to start with the discussion of question 1, part D. So let's start with the discussion of this particular past year question paper. So let's read part B. For a three variable regression model, total sum of squares is always equal to the sum of explained sum of squares plus residual sum of squares. Obviously, this statement is true. Students can watch and revise my lectures on multiple regression. For those who have subscribed to my complete course for Economics Honors Semester 4, Econometrics, you will see that in my lectures on multiple regression, I have done all the necessary proofs, where one of the proofs I had done was to show how the total sum of squares is equal to the explained sum of squares plus the residual sum of squares for a three variable regression model. Okay, so I'm quickly coming to the whiteboard just to do the proof and revise this with all students again. This is Delhi University Exam 2024. Name of the course is Introductory Econometrics. Introductory Econometrics. And this lecture is recommended for students pursuing economics honors from Delhi University, particularly in their semester 4. Okay, so we are looking at question 1 within question 1 part D. Okay, so we need to prove that for a three variable linear regression model, for a three variable linear regression model, total sum of squares is equal to the explained sum of squares plus the residual sum of squares. Okay, so first of all, let's look at a three variable linear regression model. I'm revising this with all students. So consider a three variable linear regression model. Consider a three variable linear regression model which looks like this. Yt is equal to b1 plus b2 x2t plus b3 x3t. Let me write this in caps lock just to show it to our students that these are all not deviations, but so yt is equal to b1 plus b2 capital X2t plus b3 capital X3t plus et. This is my three variable sample regression function, SRF, sample regression function. Okay, so from this equation, I can just write that what will et be? It will be yt minus b1 minus b2 x2t minus b3 x3. Okay, and if I write it in the deviation form, how will it look like in the deviation form? So let's call this as equation number 1. Okay, so writing equation 1 in the deviation form. Deviation form means when I take the deviations from the mean. So I get small yt equals b2 x2t plus b3 small x3t plus et, where small yt is capital Yt minus y bar, small x2t, let me write this clearly, small x2t is capital X2t minus x2 bar, small x3t is capital X3t minus x3 bar. Remember guys, E bar is 0 because the sum of the residuals is 0. Again, students can subscribe to my complete course for introductory econometrics. You're going to find in-depth discussions in my lectures on introductory econometrics course. Okay, so what I've done is for equation 1, I have taken the deviations from the mean. So small yt is just capital Yt minus y bar. Small x2t is capital X2t minus x2 bar. Small x3t is capital X3t minus x3 bar. And remember b1, when I take the deviation of b1 from its mean, the mean of b1 is b1 only. So b1 minus b1 is 0. That is why b1 disappears here. Because if I take the deviation of b1 from its mean value, the mean value of b1 is b1 only, because remember, mean of a constant is the constant itself. So mean of b1 is b1 itself. So b1 minus b1 is 0. So now we are focused on this equation which we have got in the deviation. Now let me start with the residual sum of squares. So if I erase the initial portion of, I'm erasing the initial portion of, we know we have to prove this equation. So now consider the residual sum of squares, which is nothing but summation et square, which I can write as summation et times et. Okay, one of the et's I can just plug in the value from the deviation from equation. From this equation, guys, what is et? Et is small yt minus small b2 x2t minus small b3 x3, right? When I solve this equation for et, this is what I get if I plug it here. So this et I am plugging as small yt minus small b2 x2t minus small b3 x. Now if I open up the brackets, I get summation et yt minus b2 et x2t minus b3 et x3. And now I can open up this whole big bracket. So if I erase this portion of, so I can write this as summation et yt. b2 is a constant, comes out of the summation, times summation et x2t. b3 is a constant, comes out of the summation. I have then summation et x3. Now recall that the sample residual term is uncorrelated with the xi's. That is summation et x2t and summation et x3t both are equal to 0. That is, the sample residual et is uncorrelated with the xi's. This is one of the assumptions we had made in our classical linear regression model and the multiple regression model as well. That means, guys, this is 0, this is also 0, and this is also 0. So what do I get? If I erase this portion off completely now, I hope students are making notes along with me. So I get my summation et square, which is my RSS. Ultimately, I get it as summation ety, because this is also 0, this is also 0. And now summation et. Now can I plug back the value of et again? What is ET? ET is YT minus B2x2t minus B3x3t times Y. What I've done is I've plugged in the value of ET again, which is YT minus B2x2t minus B3x. And now, what do I get? If I open up, I get summation YT minus summation YT square. Or let me do one thing, let me open it in the end. Let me multiply first. So YT into YT square minus B2x2t YT minus B3x3t YT. If I open up, I get summation YT square minus B2 is a constant comes out of the summation times x2t YT. B3 is a constant comes out of the summation, I get x3t YT. So if I erase this initial portion off, students can see we have almost got the result. So I have got summation ET square as summation YT square minus B2 summation x2t YT minus B3 summation x3t YT. So I can write summation YT square will be summation ET square plus B2 summation x2t YT plus B3 summation x3t YT. Now students can see this is my total sum of squares, which is summation, the deviation of actual y from its mean squared up. This is residual sum of squares, which is nothing but the deviation of YT from the estimated value from the regression, YT hat. Summation YT minus YT hat square is your residual sum of squares. And this term is explained sum of squares, which is nothing but the deviation of YT hat from the mean Y bar. By definition, total sum of squares is the sum of the squared deviations of the Y value from its mean. The residual sum of squares by definition is the sum of the squared deviations of the actual Y value from the estimated regression. The explained sum of squares is the sum of the square deviations of the estimated Y value from the mean squared up. So I have shown that the total sum of squares is equal to, I have shown that the total sum of squares is equal to residual sum of squares plus explained sum of squares, which is what we have to prove. So hence, so I can say therefore the given statement is, we have to see whether the statement is true or false. It's true, and I've shown it. I've proved it to all students why it is true. Okay. So coming back to the question paper, let's look at part E. It can easily happen that the F statistic is significant while the T statistics for the explanatory variables are not significant. True. This happens all the time when we have multicollinearity. One of the ways in which you can diagnose multicollinearity is that most of your T variables will be insignificant, but if you do the joint hypothesis testing, your F statistic will come out to be significant. So I can come to the whiteboard and I can write this for E. You can see that when the regression model suffers from multicollinearity, when the regression model suffers from multicollinearity, that is linear relationship between the explanatory variables, when the explanatory variables tend to be correlated items. That is, I can say, linear relationship between the explanatory variables which is my xi's, it may happen that the t statistic, it may happen that the t statistic for a few independent variables, the t statistic for a few independent variables turns out to be insignificant, which makes you accept the null hypothesis of the set coefficient equal to 0, but the overall f statistic turns out to be significant. Indicating that all the explanatory variables jointly have a significant impact on the dependent variable, which is y. So when the regression model is suffering from multicollinearity, which is almost a near linear relationship between the explanatory variables. Okay, students who subscribe to my complete course for Introductory Econometrics Semester 4 of Economics Honors, you will see that I have done multicollinearity in depth in my lectures. Okay, so in case of multicollinearity, if you do individual hypothesis testing, you will see that one or more of the t variables turn out to be insignificant. If you do t tests on individual variables, independent variables, it might turn out to be insignificant, which might want you to believe that individually some of these variables have no significant impact on y. But if you do the joint hypothesis testing, where you use the F statistic, that will turn out to be significant, indicating that jointly the independent variables do have a significant impact on the dependent variables. So in multicollinearity, it may arise that some of the variables individually have no significant impact, but jointly they have a significant impact. So I can say that the given statement is true. The given statement is true. Okay, so if I come back to the question paper, it can easily happen that the F statistic is significant, but the T statistics are not significant, and it happens mostly in the case of multicollinearity. Okay, so the last statement, in a regression model with the intercept term, the number of dummies for each quantitative variable must be one less than the number of categories of that variable. True. The number of dummies we should introduce in the regression should be one less than the number of categories. If we do not do that, we fall into the situation of the dummy variable trap. Students who have subscribed to my complete course for Introductory Econometrics Semester 4 of Economics Honors, you will see that I have discussed dummy variables and the dummy variable trap case in quite depth in my lectures. So when you fall into the dummy variable trap, you get into a situation of perfect multicollinearity. Okay, so if I come to the whiteboard, the last statement is true. Statement F is true. The number of dummies introduced in the regression model must be one less than the number of categories. Otherwise, we fall into the dummy variable trap. Which is a situation of which is a situation of perfect multicollinearity. Which is a situation of perfect multicollinearity. Okay, and then students can explain, you can explain dummy variable trap. You can explain dummy variable trap in depth from my lectures on dummy variables. Students who have subscribed to my complete course for introductory econometrics, you can explain the dummy variable trap in a bit more depth from my lectures on dummy variables. When you watch my lectures on dummy variables, you will see that I have explained dummy variable trap also using an example. So you can use that example in your answer also. Okay, so this is where I stop in this particular lecture. We have done question number 1 completely. It had parts A, B, C, D, E, and F for true and false. We have solved all of them. In the next lecture, I'm going to start with the discussion of question number 2. So I hope all students have enjoyed this particular lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divideschoolof economics@gmail.com. This is where I stop in this lecture.